let's look at try 10. Okay, for try 10, the question wants us to find the equations of the tangent to the circle that has the equation x squared plus y squared minus 4 equals to 0. Okay, then after that, which are perpendicular to the line. So these tangents are perpendicular. Okay, to the line x plus y equals to 1. Alright, so these tangents must be for this particular circle and then also perpendicular to the given line. Alright, seems a bit difficult if we actually don't draw a diagram, so I think let's just draw a diagram to understand the entire question. So we have some circle and then we want to actually find out tangents, right? And then this tangent is perpendicular to some line x plus y equals to equals to 1. So maybe the line is, for example, this. Okay, we know that this will be a downward sloping line because after all this one will give you y equals to negative x plus 1, right? And that is a negative gradient, so therefore it's downward sloping. Okay, then after we want it to be perpendicular, so therefore we will probably be seeking for a line that's something like that. And then after that also something like that. Okay, they need to be perpendicular. So we need to find out what's this two. Right? Okay, so how do you think we could approach this question? Okay, maybe let us start unpacking from knowing that it's perpendicular to this line first. Okay, we already said that it could be manipulated to get this. Okay, what kind of information could we derive out of this? Okay, we can find the gradient of this line. Okay, so this gradient will be equals to negative 1, which will imply that the gradient of the tangents will be 1. Okay, but so what? Okay, we know this gradient of the tangents, then what else could we do to find out more about these tangents? dy dx? Okay.
The tangent to the circle.
Tangent to the center, to the circle. Why then? What about?
Equation to find the diameter.
Use the equation to find the diameter. How would
Find the radius first.
to find the radius? Okay, let's just try that. So x squared plus y squared minus 4. That will mean that x squared plus y squared equals to 4. So we will be able to tell this one is a fairly simple equation. We can tell that the center is at where? Huh? Where's the center? What's the coordinates of center? 0, 0. And then after that, the radius is going to be 2. Okay, knowing this information, let me just label it here. Is it actually helpful? Equate what line to the center? X plus y equals to 1. Equate it to the center. Equate it to the circle. But they are not necessarily intersecting, you know.
So since why you find the perpendicular line that's passing through 0, 0?
Find the perpendicular line that passes through 0, 0.
To the both the tangents.
Okay. So this perpendicular line will have the same gradient as this one, right?
Yeah.
Okay, and that line actually is very simple to find, isn't it? So if I want to find out this one here, okay, this will have the same gradient as y equals to negative x plus 1. Let me just not formalize it yet. Okay. So because it passed through the origin 0, 0, so this equation of the line will actually be y equals to negative x, right? But how does that help?
So
So it intersects the circle. Then after that, we will be able to find the section points.
You can find the point of intersection between the tangent and
Okay.
using the length of the line segment.
Using length of line segment. So let this be some point. Then after that, then you have to have two equations because that will be A and B, right? That seems a bit hard, tedious. Okay, why not? With this concept that y equals to negative x, okay, we equate them to the circle because it will actually pass through the circle, right? That's what we can see over here, right? So, okay, so equation of how should I phrase it? Of line of normal of the normal okay, so equation of the normal of the tangents is actually y equals to negative x. So this will be our equation 1. And then after that, this is our equation 2, right? Our circle. So let's just do a substitution. Let sub 1 into 2. Is it? Okay, so, sorry, or negative square root. Right? Then after now we can find out what's the y coordinate. That would actually be negative square root 2 or square root 2. So the coordinates of the 2 points would be these two, right? Then could we actually find out the equation of these two lines already? Okay? Okay, so y equals y minus away negative square root 2 equals to the gradient of tangent is 1. It's minus square root 2. So these two are the equations. Right? Sorry? What's my what? What's my method? Does it matter? You already have your own method. Huh? Okay, are you comfortable with this? Okay, another method that you could do, which was what I originally had in my notes, right, was that at the point whereby I found the gradient of the tangents, okay, I will be able to know that the equations of the two tangent line will have to form a equation, a linear equation, right? So y equals to x plus some constant k. Do you agree? Okay, the tangents will have to obey that equation, y equals to x plus some constant. Okay, whereby the gradient is 1. So we know that the tangents will definitely intersect with the circle. Okay, so I just need to find out what is this constant k. Right, so I can have this as my first equation, and then likewise I'll still keep to having my circle equation as my second equation. And then I do my substitution. Okay, and then I will be able to find out what is the value of k. Let me, oh wait. Okay. I leave the idea first. Okay, have you all done finish copying? No? Okay, you all finish copying this first. Then I'll continue with the idea. or wrong answer or anything that's easier. Are we done with the front part? Yeah. Because the equation for the standard form is x minus a bracket square plus y minus b bracket square equals to r square, right? So if this is x square, it is also x minus 0 square plus y minus 0 square minus 4 equals to 0. Right? So you can see the center is a t. That's it? Okay. Okay, any questions before we go into a different method? Can I erase already? Shaolun, here you go. That part at the end, huh? Okay, let's go with another point of view. Okay, so just now I mentioned that knowing that the gradient of tangents is 1, okay, we know that the equation of the tangents satisfy y equals to x plus k, where k is a constant. Right? Okay. Then after that, because we know that the tangent will definitely intersect the circle, so we can do our simultaneous with the equation of the circle. Okay, so sub 1 into 2. But then when you do the substitution, you'll be faced with a problem, right? You do not know how to actually proceed from here. Okay? But at this point, does anyone know how to proceed from here? Okay, we want to find out what's the value of k because our objective is to find the equation of tangent. Okay, and that will only be able to solve. We will only be able to solve it if we know the value of k. Right? Sorry? Yes, we will do discriminant. Okay, because this is a tangent, okay, with a curve, right? And tangents will touch the curve at one point only. So therefore, this is a quadratic equation. We can do discriminant, and discriminant will have to be equals to what? 0.
Oh my god, I forget everything.
Okay, so b square minus 4ac. The discriminant itself will be 2k square minus 4a. C is k square minus 4. Okay, so we get negative 4k square plus 32 for the discriminant, and this will be equals to 0 because we're looking at tangents, right? So we will be able to solve for the value of k. Okay, k is equals to plus or minus square root 8. And if we remember how to do our simplification of surds, square root 8, 8 is 4 times 2, so it's actually equivalent to 2 square root 2. Okay, so checking our answers now. Alright, if I were to substitute in k equals to 2 square root 2 into here, I'm actually going to be getting this answer. And then after that, for the negative 2 square root 2, I'm also getting this answer. Okay, so both methods will actually work. Last question. Okay, let's look at exercise 9.2, question 15. I erase already. Okay, so in this question, we want to explain why any line that passes through the point negative 3, 1 cannot actually be a tangent to the circle with equation this. So the question is actually asking you that, or rather kind of indirectly telling you that this line will not be able to be a tangent already. So they want you to explain why. Okay, so not being able to be a tangent, your diagram will actually appear in two different ways. Okay, one of it is that intersect. Okay, your tangent, I mean that's actually, there's intersection. So one of it is whereby the tangent or the line itself, okay, it is totally away from the circle. Or otherwise, okay, the line will actually intersect the circle, okay, at 2 points. Okay, so this is what it means by cannot be a tangent. Correct? Okay, so how do we actually verify this? Okay, we know that at this point, that this line actually passes through a point negative 3, 1. Okay, I have no idea which case is it. Right? Then after that also, we know that the equation of the circle will be this. Why can we assume that the first possibility is impossible?
Because like another line will
Huh?
any line that passes through negative 3.
I could so for any line, so actually you're covering all the cases, right? So it will be like that, and then like that, and all that. Sorry, repeat. So that possibility is not true. Okay, so what Brian is saying is that we do not actually need to consider the case whereby we have this one.
Why?
Because the question actually says that any line, right? Okay, so as long as I can find one line, right, that will actually cause this intersection to happen, and it passes through negative 3, 1, then it is not possible to have any line that can be a tangent to AD. Okay, we just have to find one counter example, okay, to actually prove this statement. Right?
You tell me no other thing.
So if you can find a line that
Because the question says explain why any line that passes through this will never be able to be a tangent to this. Okay? Yeah, so we just find one case and then we can be able to prove it already. Right? Okay, so in this case, then we just scale down to this and divide it. Okay, then after that, how do we go about showing it, explaining it?
Plug in the
Discriminant. Now it has two variables, and then there's nothing much for us to work with. Okay, maybe let us start with the
gradient.
equation of the circle first. Okay, the information that we can get from this equation of the circle. Alright, we can get the center and we can get also the radius. Right, so let's just get that out first. So so we expand our standard form. Then after that, I do comparing of coefficients. So the radius will be 5, then the center will be at negative 2, negative 3. Hang on. Let me think. Negative 3, 1. Sorry? What thing negative 3, negative 1? What thing negative 3? The question gave negative 3, negative 1. Oh yeah, sorry. Okay, so now that we have found out the center and also the radius, right? Okay, actually our point, right? Why is it that it's always outside the circle? Can be inside the circle, right? Okay, we do not know, right?
Why
Why does it have to be?
outside the circle?
Actually, the gradient of the people will be
Yeah. Okay. So in this case, if it's outside the circle, there might be actually a tangent, right? But inside the circle, then it will not have a tangent, right?
So we have to show that it's
Okay.
inside the
So
circle.
yeah, we have to go about showing that inside the circle, it will actually not allow us to have a tangent. So we need to verify how is it that it's inside the circle. Okay, so how do we verify that? We'll find the length of the segment between the point and also the center. Okay, so you find that the length of the line segment between the point that we want at the center will be 2.2360, okay, truncated 5 SF. Alright, so this value is actually lesser than the radius 5. Okay, so therefore, we will be able to conclude that less than 5. You see, what does it say?
So we need to find the line segment between.
Hang on, let me finish this first. Just and behind that doesn't show
Oh, so that it is inside the circle and not outside.
Yeah.
Okay.
Okay. Brian, just now when you said when you remove that particular case, why do you say we remove that case? It was actually the same case. What do you mean?
Because when it's you see it's like that. It's actually any line, so it's actually the same as the second case.
Same as the second case. Yeah, but the question is actually asking all the lines, out of all the lines that are possible to be around, none of it can actually be
After that, I
accounted.
interpreted
So actually,
all the lines.
yeah, so actually, just now we shouldn't have eliminated this. Right?
But it's still the same case. It's the same case.
Yeah.
Yeah, it's either inside or outside.
Uh-huh.
So you had two cases that are outside.
Oh, okay, if you want to say that.
So it can be like this. So it can be straight down.
Get what you want.
So what are you?
Huh?
What?
Never mind. I go and think first. It's the same case because
the one to the
It's just how you draw the line. So
So
you're looking at two cases whereby one is inside, one is outside. The point is inside and outside. Then after if it's outside,
and then can it imagine like so shaded to me?
any of the lines
I
also
also
never
never line was that it's actually like a circle. I don't know, I think it's outside.
Can I go and think about it? Yeah. Okay, maybe let me just formalize everything over here first again. Okay. So when we want to actually answer this question, explain why any line that passes through -3, -1 cannot be a tangent. Okay, we want to look at all the possibilities. Okay, why is it that all the possibilities will never allow it to become a tangent? Okay, so this point -3, -1, we do not know whether is it inside the circle or outside the circle. Okay, until we are able to look at the length itself. Okay, and then cross compare it with the radius value. Okay, so that's why. Okay, using the equation of the circle, we will go on to find out what are the details of the circle first, whereby we find the center and also the radius. Then after that, we look at the length, okay, of the line segment between that point and also the radius, so as to see and justify that this point, okay, is it inside or outside the circle. Okay, but regardless of the case, whether it's inside or outside, okay, as long as this point, okay, so if we see that this point is actually inside the circle, okay, surely it will end up having to intersect the circle at 2 points. Okay, if it were to be outside the circle, then we will not be able to go on to actually we will not be able to go on to find out whether it will be a tangent or not, because I can always definitely have one point over here, but then I can draw a line such that it will be a tangent to the circle, right? Okay, so that possibility will definitely have to happen, right or not? Correct? So if the point were to be outside the circle, this case will not be able to hold, because definitely I will be able to draw any orientation of the line such that it will have to be a tangent.
So you just remember like there are outside circle, then it's two tangent, then on circle and one tangent, then inside circle one tangent.
Circle also two tangent.
But this point does not. Wait, repeat again.
Outside circle, inside. Yeah, it's either like that, just that it's main tangent. So if outside, then it's on the center, then on the
Outside the circle is two tangent. Oh, okay.
What you say?
If outside the circle, you can have two tangents.
then if
On the circle, it's only one tangent. Yeah, inside the circle is no tangent. Yes, you can That's true lah, that's true. Okay, that's true. Yeah. But I don't know whether anybody has really discovered such a theorem. Maybe there are people on the next side. Okay. Since like that, okay, we are done with chapter 9.
Go to chapter 10 now.
Okay, exercise 9.2 homework. Point outside the circle.
Nobody wants to use.
Question 8. Then this one got quite a few. Okay. 8, 10, 13, 14, 17. Due by Thursday.
yes. Oh, that's showing shit.